Good, you are back. A good day to all of you. How are you feeling today? Well, I feel great because we are going to study this morning resolving a force. I call it part 1 because basically there are 2 types of situations for us to resolve a force. And in this situation, you find that this is the first type of a situation whereby we have an object that is placed on an inclined plane. Now, just like what you see in front of you, just like what you see on the computer screen, that is the situation that we will look at. Okay, a word to encourage all of you. To understand physics, it is not a question of memorizing facts and formulae. In fact, to understand principles like this, it is very simple. All you have to do is to understand the first principles, understand the concepts, and then that will unlock the key, unlock the doors to the world of physics. And do not forget, after you have understood concepts like this, you must try out past year questions or similar questions to examination questions. Then you will understand the concepts much better. Alright, this is a situation where you see in front of you. Of course, I have drawn it slightly different for the purpose of making it easier for us to do calculations in a while. You are given a problem like this to solve. In the diagram below, the weight of the ball is 10 newtons. Calculate the force F which is parallel to the smooth inclined plane. In other words, now you are given the weight of an object like this, like the ball, same weight, 10 newtons. But as you hang this to a spring meter or to a force meter, the spring balance, you will notice that there is a certain force acting in this, along this inclined plane. So the reading that I have here, I'm not going to tell you what reading it is, but this reading is actually the reading of F, which is in my question. You see the point now? Can you relate the two? So the reading here in the spring balance is actually the value of F that I am asking you in the question. So let us now go to the first principles. I'll explain it. Just give me a few seconds. Let me enlarge this. Okay, very good. Now I'm going to ask a few very important questions. What is the weight of this object? 10 newtons. Just like in the question, it is 10 newtons. So, the first thing that I would like you to understand really well is this. No matter what angle that I tilt this plane, no matter what angle I tilt it, alright, remember that the weight of the object is still 10 newtons. And as I tilt it at a bigger angle, what do you expect of the reading? I'm sure you can tell me, oh uncle, it's bigger. You are correct. Okay. So when it is exactly vertical, this will give me the biggest reading on the spring balance. And remember, in this inclined plane, the reading on the spring balance is the value of that F that we are working out. So, the maximum value of F, can anyone tell me? What is the maximum value of the value of F? No friction? Very good. I heard some of you saying, it is 10 newtons, uncle. You are correct. In other words, what I'm saying is this. The value of F can never be more than 10 newtons. Because 10 newtons is the weight. You say, okay, uncle, I understand. Can you now explain to us why you are explaining that with so much emphasis? The reason is this. Let us take a look at the diagram now. We have to construct a triangle so that we can calculate the value of F. What I'm saying is this. Many a student makes this mistake. Alright, I'll show you the mistake that is being made. Many a student, they will just conveniently complete a triangle and they say, alright, this is F, okay, this is the weight. Do you know what I mean? Now, if a student were to use this as the triangle, can you please tell me, you calculate F here, obviously, in this diagram now, F is more than 10. But just now what did we say? F must never be more than 10. It can never be more than 10. So, in other words, we need to erase this, alright? That is wrong teaching, okay? Or wrong learning. Some students make the mistake. Remember, F can never be more than 10. Very good. So then, what it simply means is this. I can construct a triangle. This is the triangle. I am going back to first principles. Can you see it clearly now? This is my triangle that I'm working up. Alright, if you want, I can give it a little bit more color. This is the triangle that I'm going to use. And in this triangle, I want to calculate the value of F. Very simple. From this triangle now, first thing, we need to work out what is the value of this angle. What is this angle? Can anybody tell me? What is this angle here? I color it. This is 90 degrees. This is 30. So what would this be? Okay, you say 60. So what would this angle be? This is 30 degrees. Alright. So now I will erase the 60. Less distractions. Okay. So from this triangle now, what would be our trigonometry function equation? F divided by 10 newtons equals to sine 30 degrees. Alright, let's write it down. F divided by 10 newtons. This will give me sine 30 degrees. So what is F? F equals to 10 newtons multiplied by sine 30 degrees. This gives me 5 newtons. You see the picture? Did I memorize any formula? No. I work it from first principles. Hey, what about the value here? Now I can tell you. It's about 5 newtons. Alright? So you can see that when there is no friction, the theoretical value that I have calculated is 5 newtons. In practice, it is 5 newtons. So this will help us to understand the situation of what we mean by resolving a force. Because we are resolving the 10 newtons in the direction of F. And what is the value of F? We worked it out, 5 newtons. So to sum it up, anytime you are given a problem like this, go back to the original situation, construct the triangle, draw the triangle, and work from there an equation. It is normally a very simple calculation problem. Then you can work out the value of F. Go back home, try other questions that are similar, and I'm sure you will understand this much better. So from now on, boys and girls, no need to memorize equations. You know, just understand the first principles. You're happy? If you're happy, I'm happy. Alright, so with this, I would like to say thank you very much once again, and may God bless all of you, even as you continue to work hard, even as you continue to study. Alright? Okay, bye. See you again next time.